What I thought I'd do is give you a little bit of a flavor of the Airman Systems Directorate and particularly talk about a number of our AI and autonomy research challenges. The Airman Systems Directorate focuses on biological, medical, and cognitive science and technology, really looking to optimize and protect our airmen and guardians to fly, fight, and win in air, space, and cyberspace. The two main enduring challenges that we are looking at in the Airman Systems Directorate are to enable, sustain, enhance, and restore multi-domain capable airmen and airman machine operations. And especially that second one, you can imagine, really focuses on how do we interact with autonomy and AI systems. Like the Information Directorate, we have several core technology areas, core technology competencies. Those, the four that we have are training, medical and operational biosciences, bioeffects, and adaptive warfighter interfaces. And if I walk through each one of those, or at least the three of those that have the strongest ties to AI, our training, CTC, really has a lot of work focused on how do we train humans and the autonomous systems together and appropriately so that they can be most efficient. We also have a large area that focuses on cognitive models that support that the AI development. In our medical and operational biosciences, CTC, they focus a lot on understanding the operator's state assessment and brain-computer interfaces. Again, how can we know when an operator might be overloaded and we might want AI to come in and help support and augment that individual, or when are they confused, so can more information be provided? How do we best interact with the autonomous systems? And then the CTC that probably has the most connections with AI, and in particular looking at trusted AI, is our adaptive warfighter interfaces. And as you can imagine, this group focuses on how do we interact with machines? How do our operators do that? And in particular, we're looking a lot at distributed operations with mixed teams, both airmen and guardians, and machines, and combinations of all the above. And we're really focused on how to enable rapid, accurate situation assessment and decision making. We also have a area particularly focused on trust in intelligent machines. For our airmen to use AI and to trust it appropriately, what is the right amount of transparency that we need to provide with those systems so that we can have that appropriate amount of trust? What kind of information do we provide our airmen to know when to overrule an AI system? How do they interact with swarms? At what point how much failure is at a point where we start losing trust? A particular example of where we've been quite involved is with the F-35 auto GCAS, auto ground collision avoidance system. And we've done a number of studies at looking at how our pilots have accepted that. Also, we did the same thing with the F-16. How have our pilots accepted those new systems that take over for them when they're flying? And what makes them trust that system? And when do they actually, want to turn it off because of lack of trust? And so what do we need to build into these AI systems to make them trusted by our operators, and so that we get the best benefit out of them? So those are some of the technical areas that we work in. And so I'd also like to talk about that human autonomy teaming research challenges that we are looking into across the board in the Directorate. There's a number of operational challenges that make this an important area to be looking into. These include the increasing role of autonomous and AI systems. These also often lead to shorter decision timelines and cycles. So how do we help our operators understand and get the right information for their decision making? There's also a lot of greater technological parity between our near peers. So how do we keep up with those competitors? Also integrated, for example, the joint all-domain operations. So our operators are having to, rather than just deal with fighters, they might be needing to deal with a cyber system or a space system or a naval system. So how do we give our operators the information they need to do the proper interaction and how to have them trained in the proper way? And this leads also to the many challenging roles that our warfighters are facing nowadays and in the future as the warfighter space gets more challenging. So digging into some of the research challenges, we have a large area looking at naturalistic interaction and communication. What's the best way for our operators to interact with these? Is it is it audially or visually or a combination or even tactily? And is it better that the autonomous system speaks to us, and what kind of language does it use? Does it help if they sound benevolent, or do they need to just provide the facts? We're finding some really interesting things regarding that and how to make those autonomous systems work well with our operators. Another research challenge area is shared awareness. If we look at most of our systems, we know lots. For example, our fighter aircraft, we have thousands of streams of data that tell us what's going on with the aircraft, and we have none about the airmen. And that's really counterintuitive if we think about when we're interacting with AI systems and autonomous systems. We want those systems to understand the airmen as well, so that they can know when an airman might be overloaded and provide additional information, or let someone else know to step in and help. So, and also, how do we share awareness and comprehension for when a system needs to hand off to a human or hand it back? And how do we get a human who's getting rehanded the stick as it is, to have the right information to be able to pick up the ball and run with it? This really is a big area of our trust and transparency and understanding research. Again, also looking at problem solving and decision making. What information does the human need, and what information does the AI system need in order to make good decisions? And really looking at dynamic and adaptive task allocation. And think about this from the point of view of, if you have an AI system or an autonomous system where we are flying it and we lose comms, how do we handle that, and how do we avoid the brittleness when it encounters something it hasn't in the past? We're also very interested in interactive learning and training that can be done with in combination and dual between our operators and the systems. And finally, looking at how to best enable team performance. And we usually think of teams as a team of humans, but now we're thinking of teams of humans and machines, and how can they be most effective in communicating. So overall, those are just some highlights of what the Airman Systems Directorate is looking at. Always focused on looking at those multi-domain capable airmen and really trying to optimize airman machine operations. I'd be very happy to entertain some questions at the end here. Thanks.